Okay, so in this video I'm going to show you um, how to build the model, to train it first and to test it. So here we have uh, multiple directories for the data. As we showed you before, we worked on 5 classes to see if uh, our model is going to give us good results, and after that we increased the number of classes to 12. And in this video I'm going to show you the model built on 12 classes. Okay, first we import these libraries, and we are in the my files directory, and inside my files we have the 12 classes directory, and we want to get the classes in a list, so we use os.list directory to get the classes names. Then we go back to my files directory, and we are supposed to pass our data to image data generator, and we are using MobileNet. So for MobileNet, the data is pre-processed in a way, so we are pre-processing them using this function, pre-processing function, tf.keras.applications.mobilenet.preprocess input, and we are resizing that to this size. And actually this function is getting the images from .flow from directory, and there are other ways to get or to get batches of data. Here we are getting the images in this way, and we are doing some pre-processing and splitting them into batches. Okay, so the result of this is 3,954 images for train, 1,130 images for validation, and 564 for test. And we are going to load some images, and these are some of the images, and these are the labels. And here, as you can see, it's one hot encoded. So when we go to build the model, we are going to use categorical cross entropy. If we have some integers 1, 2, 3, 4, we are going to use sparse categorical entropy, cross categorical entropy. And we are going to use MobileNet and do some fine tuning to it. First we import it, then we see the summary of the model, and the trainable parameters here are 4 million. So we are not going to train 4 millions, we are going to fine tune it. So we are going to get all the layers in this model except the last 5 layers. Actually we are going to get all layers including this one. And actually we are going to change the shape of this input using flattened layer, and then we add the softmax layer and we have 12 classes, so units are 12. And this is like the functional way of building the model. So we pass x to this layer and we pass x to this layer. Then we build the model in this way: inputs model.input and outputs equal output. And for this, so what we are doing is that we are iterating through the layers of the model, and we want to train only 1 million parameters. So we are going to say that layer.trainable equal false. So that means that when you iterate through the layers, keep the weights of this layer as they are and don't add them to the trainable parameters. So when we go and see the summary of the model now, we'll see that we have the global average. We added the flattened layer to change the shape to 1024, and then we added the dense layer. We have 12 classes, so 12, yeah. And the trainable parameters now are 1 million. So you may ask, why did I choose the last 23 layers, not to keep them at the R and to train them? It's just after some experiments by someone on YouTube, he suggested that 23 is a good, it makes good results, so that's why I choose 23 and I can change it, and that will just increase the number of trainable parameters and increase the time required for each epoch. And okay, for the next step, we are going to train the model. We used Atom Optimizer, learning rate 0.0001, loss categorical cross entropy, and the metrics accuracy. And here, this is one way to see the history of the model. Okay, and we use the callbacks because we need to avoid overfitting and to save the model in the best case. And as you can see here, we pass the input train batches, we pass the validation valid batches with number of epochs 30, and these are the callbacks and variables to see the information of the training. So as you can see, we started with 0.7 for accuracy and 0.7 for validation accuracy, and that's good sign. Loss was 0.9 here and 0.7 here. Then it was reduced significantly to 0.23, and here was 0.39, and then it jumped to 0, 0.5, 0.05, and then we continued till epoch 20, and as you can see, the validation accuracy and the accuracy are very close, and here just 0.19 and here 0, so it's still good. Now we are going to predict. Before that, I'm going to show you something. In the data we've used in this model, the number of images in each class are not the same. for example, Angelina Jolie. Oh, that's one photo. Okay. I mean, if you see here, we might have 400 photos or 500 photos. I don't know. But for someone like Morgan Freeman, this actor, we only have 200. Okay, we only have 200. So when we are going to build a confusion matrix, the numbers will be different for each class. But you will notice uh, the like false or the false predictions will be just less or equal to 3 uh, uh, wrong predictions. So here we get in the test and images and labels from test batches, and then we plotting the images, and here these are the classes. Then these are the classes one hot encoded, and we can use this method or dispatches the classes to get it like integers of all the batches, and we are going to predict using model.predict, and after that we are going to use argmax to get the index of the maximum value, and like the softmax activation function returns a list of some values, and the maximum value in that list refers to the index of this element, refers to the number of the class, the predicted class. So we used argmax to get the index, and in order to convert this to integers, as you can see it's integers here, sorry. And then we are going to build the confusion matrix using this function. I got it from course on YouTube. Okay, so we are going to pass the test labels and the correct ones and the predicted ones, and then we are going to get this. As you can see, the numbers here in this diagonal refer to good results, good predictions, and if you can see, there are less than 3 wrong predictions on each class, and that's really good for this model. And now we are going to plot the loss and the accuracy. So here, as you can see, the gap between the loss and validation is not that big, and here in the accuracy they are very close to each other, less than 0.1 difference. And then we save the model. So that's all for this video, and actually before I get to this point, I had a lot of like a lot of times that I failed to build a good model. I used VGG16, and I also used some simple models. Sometimes I removed most of the classes, and I just used two classes to know if the model performs bad or worse if I increase the number of classes. And I tried a lot, and the turning point in this project was that when I was searching for a video, and the turning point that helped me build a good model was in the file data cleaning. The point is that in this project we have to crop images before we build the model, and this is the function using this R cascade frontal face model. That function crops the image to include just the face. So that was the turning point for this project, and I found it on a YouTube video, and it was really helpful for me. But before that, I passed through many failures, or it's good for learning, and I'm really happy that I reached that point. I hope that project is something that can be evaluated as a good project, and I will include all that in the GitHub directory. And thank you for listening to me in this listening to me and watching me till the end. Thank you. Bye.